Alright, another application of solving quadratics would be able to solve a system of equation algebraically. So, algebraically means you're going to do it by hand. So it means you're going to write it out and solve it by hand, as opposed to graphically, which means you would graph it and find the intersection points. But in this case, we have two equations here. These are two different examples. We'll do both of them this video. We have 4 examples this video. So, what we're going to do is solve by substitution. And this says y is x squared plus 4x. And this says 2x minus y equals 1. So you could solve for y in either of the examples. If I wanted to manipulate this equation, I could say that this is, let's subtract 2x from both sides. So, excuse me. Let's subtract 2x from both sides and say that negative y equals 1 minus 2x. And let's divide by negative 1. Y equals 2x minus 1. So all I did was manipulate this. So now this says y is 2x minus 1. But y is also x squared plus 4x. Well, if y is that, and y is that, that means these things are the same. So here was our original system. Our original system were these two. I manipulated the second equation to solve for y. So now I could set these things equal to each other. X squared plus 4x equals 2x minus 1. Now, another thing I could have done, for those that just want to save some time and do a little bit of less work like me, this says y is x squared plus 4x. So I could have just said, well, if y is that, then why can't I just plug it in for that? You can. And in fact, that's what we're going to do in the next example. So I solve for y in both of the equations, and then I set the equations equal to each other. So now I have a quadratic with respect to x, not x and y. So we're just going to solve this like we do any other quadratic. We're going to put it into standard form and either factor, complete the square, or use the quadratic formula. So I'm going to subtract 2x from both sides, giving me x squared plus 2x. I'm also going to add 1 to both sides, equals 0. I'm going to complete the square. Take 2 and divide it by 2, that gives me 1. That's my factor. Square it, you get 1. That's the number I add and subtract. So x squared plus 2x plus 1 minus 1. Don't forget that other plus 1. We already factored these. Equals 0. Take the square root of both sides. X plus 1 equals 0. Therefore, x equals negative 1. Now, the problem here is we solve for x. But a solution of a system of equations is an ordered pair, not an x value. We still need to find the y value. But we know that y equals 2x minus 1 from up here. So let's plug in 1. Therefore, y equals 2 times negative 1 minus 1. 2 times negative 1 is negative 2, and negative 2 minus 1 is negative 3. So the solution is negative 1, negative 3. Alright, now this example, we have y is x squared minus 4x plus 5. But 2 times that same y is x plus 6. Instead of going through all these hoops here, I'm just going to say, well, I know y is that. So I'm going to plug this in for that. That's what it says. Y is x squared minus 4x plus 5. So 2 times y is x plus 6. 2y x squared minus 4x plus 5 equals x plus 6. Let's clean this thing up. 2x squared minus 8x plus 10 equals x plus 6. And now we'll put this into standard form. Subtract x and subtract 6. Subtract x and subtract 6. So 2x squared minus 9x plus 4 equals 0. Now this one I'm going to use the quadratic formula. I have a equals 2, b equals negative 9, and c equals 4. Now I can plug it into x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals 9 plus or minus the square root of 81 minus 4 times a times c all over 2a, 4. So, let's see, negative 4 times 2 is negative 8, and negative 8 times 4 is 32, and 81 minus 32. X equals 9 plus or minus the square root of 81 minus 32 all over 4. Let's see, 49. So 81 minus 32 is 49, and the square root of 49 is 7. So x equals 9 plus 7 over 4. X equals 9 minus 7 over 4. 16 divided by 4 is 4. And 2 divided by 4 is 1/2. So that means we have two ordered pairs here. We have the x values. We do not have the y values. We still have to go up here and find out what the y values are. So I'm running out of little room here, so I'm just going to pull out another piece of paper and continue working down. So again, I had x values of 4 and 1/2. I'm going to rewrite my equation. Not the x squared. That's going to be a pain in the butt to work with. So I'm going to say I know that 2y equals x plus 6. And this is going to help me solve for y. So now let's first plug in x equals 4. 2y equals 4 plus 6. 2y equals 10. Therefore, y equals 5. That means this yields a solution of x equals 4 and y equals 5. Let's now plug in 1/2. 2y equals 1/2 plus 6. 2y equals 1/2 plus 12 over 2. 2y equals 13 over 2. Cross multiply. 4y equals 13. Therefore, y equals 13 over 4. So now the x value was 1/2. The y value is 13 over 4. So my ordered pair is 1/2 13 over 4. Alright, we'll do one of these because the video's getting a little long here. So I just wanted to show you how to deal with some circle and linear systems. So here we have x squared plus y squared equals 24, which is the equation of a circle. We have x plus y equals 8, which is the equation of a line. So now what I'm going to do here is solve for y and plug it in up there. So let's manipulate this and say y equals 8 minus x. Now that is what I'm going to plug in up here. So my new system is x squared plus y squared equals 24 and y equals 8 minus x. I'm just going to take this y and plug it right in for that y. But I'm squaring a by. Don't forget, you square a by, you get a try. So x squared plus 8 minus x squared equals 24. X squared plus, let's see what we got here. 16 minus, that's 64, not 16. 64 minus 16x plus x squared equals 24. And now we can combine like terms. X squared and x squared. 2x squared minus 16x. And now I'll subtract 24 from both sides, giving me a positive 40 equals 0. Let's factor out a 2. X squared minus 8x plus 20 equals 0. Let's see if this is factorable. Multiples of 20 are 5 and 4. Nope, this is not factorable, so let's just divide by 2 so we could get rid of that 2. Just because we have 0 on the other side. It's divided both sides. So let's complete the square. Negative 8 divided by 2 is negative 4. So x minus 4 squared. Square it. 16 is what I'm adding and subtracting. X squared minus 8x plus 16 minus 16. Don't forget that positive 20. So we already factored these. So we have plus 4 equals 0. Subtract 4. X minus 4 squared equals negative 4. Take the square root of both sides. X minus 4 equals positive or negative radical negative 4. Uh-oh, that's an I term. X equals 4 plus or minus 2i. which means I have imaginary solutions, which means I have imaginary intersection points. These graphs do not cross.